Question number 15th says, let I be any interval disjoint from -1, 1. Okay. Prove that the function f given by this is increasing on I. Okay, let's take a look at this interval. So, disjoint from -1, 1 would imply that this particular region should not lie in that interval, right? Okay, let I be any interval disjoint from -1, 1. Prove that the function f given by this. So, fx is equal to x plus 1 upon x. This is what we have. Okay, so what about f prime x? F prime x will be equal to 1 minus 1 upon x square, which is simply equal to x square minus 1 upon x. And for analyzing the sign scheme, let's factorize the numerator. This is what you get. Okay, the critical points -1, 0 and 1. That's what I observe. Okay, the sign of f prime x for values greater than 1 will be equal to what? For values greater than 1, beyond 1, you'll have, let's take for example 2. This will be positive, this will be positive, overall will be positive. And we are interested in this values below, before -1. Let's talk about those values. Before -1, let's take -2. This is -2 plus 1. What will that be? By the way, this is x square in the denominator. Let's not make a mistake on there. This is -2. -2 plus 1 will be negative. -2 minus 1 will be negative. -2 square is positive. So, negative, negative and positive will be overall positive. Okay. So, in this interval the function is increasing. In this interval the function is increasing. These are disjoint intervals from -1, 1. Yes. The important thing, the one more important thing, I will draw the graph of fx equals x plus 1 upon x in front of you. Okay. And how do I draw the graph of that? X plus 1 upon x. Now, if you observe, what does f y is equal to x look like? Y is equal to x is this line. What about y equals 1 over x? Y is equal to 1 over x is this and this curve over here, right? This curve which is decreasing, becoming very, very close to the x-axis, and that one, right? Let me erase this. This is not required. Now, once you know that graph, then the graph of x plus 1 upon x is similar to, is something like this. I'll explain that over here. Let me draw the second graph again, and this one. This is y is equal to 1 over x. Now, imagine adding these up. So, you begin with a 0 and very, very close to infinity value, and then this particular value decreases very fast, this particular value increases not so fast, but then it becomes very, very close to 0. So, the overall output somewhere around this point will be very, very close to this, right? That's what I observe. And both the values are positive. So, I'll be always above this line, and yes, this is the kind of shape that you will get. This is the kind of shape that you will get. If you observe, the derivative is 0 at this point and this point. Yes, the derivative is 0 at this point, means this is the point at which the derivative becomes 0. The slope becomes 0 actually. This is 0.1. And the value of the function at 1 is 1 plus 1 upon 1, which is 2. This is the least value of this function when you consider values which are greater than 0. X-axis and y equals fx is what I am talking about. This is 0. Let's talk about values below, before x equal to 0. So, you have this line and this graph. Similar graphs will be obtained. Similar graph will be obtained over here in this manner, something of the sort. And this value will be -1. This point will be -2 over here. That's the peak on this side of the graph, right? That's the kind of graph that you'll get. Now, analyze the shape. Analyze the shape. From -infinity to -1, the function is increasing. Then from 1 to infinity, the function is increasing. And if you consider any interval which is disjoint from -1, 1, you will observe that the function is increasing throughout. Function is increasing throughout, if you analyze any interval. Right? Is that okay? Yes. Any interval disjoint from -1 to 1. Okay. Is that all? Yes, that is all that you have. We have proved that this is increasing on the interval I. One very crucial thing which you should note over here is that we can take, an interval can be taken on this branch only, an interval can be taken on that branch only. You can also take an interval which comprises of partly this branch and partly this branch as well. And for that interval also, if it is just disjoint from -1 to 1, the function will be increasing. Let's say I take from -2 to 2, except for this interval -1, 1. The function will be increasing throughout. The function will be increasing throughout. From -2, this function increases, and then this function increases again up till 2. That's what you can observe. Any particular subset of that interval, the function will be increasing. This one, right? That's what you can observe from the graph as well. That is some extra bit of information which will be helpful for you, right? But otherwise, we've seen that this is positive, implies fx is increasing in this interval and this interval. This greatest value here and the least value here is bigger than this value, right? Therefore, the function is increasing in any interval which is disjoint from the interval -1, 1. That's all. That's a complete analysis of this question over here.